All right, what we're doing is today we are going to be talking about more on System D, okay? And what we've got going is System D. Some of the stuff I was poking with on System D does not work even on Ubuntu 18, which wasn't that long ago. So what makes things interesting today is what you're demoing or what I'm showing you is one reason why you want to be part of the acm.org. What this is you are looking at a free textbook, or well, it's not even a textbook. It's a free book from the O'Reilly Learning Center, Learning at O'Reilly through the ACM, and it's completely on the topic of System D, okay? So there's a lot of interesting stuff happening in the world of System D. And here's the part I want you to make note of. Some of the things in System D that are being developed specifically by Intel and AMD and Google, these companies that have Microsoft, that have a vested interest in getting the Linux kernel to be easily managed remotely and in the cloud. I found a very interesting add-in for System D, and it was written by a full-time developer at Intel. And I'm going, oh, this is serious. When the big boys get involved like this and they start doing, adding code to things like, oh, I hate System D, you need to pay attention because there's something to it, okay? Now, this book that I'm bringing up, that I'm showing you is, so let's go back to the beginning here. I'll show you what the book is. It's the whole book, and it's, if you read it, it's called Linux Service Management Made Easy with System D. And it goes through the history of it, which is very handy to know. If you get into computing without any understanding of history, you're going to have to learn it the hard way and say, oh, why am I reinventing the wheel? Okay. And then they talk about security and the controversy, the religious wars. Okay. Now I'm going to open another window that isn't shared yet. So let's see if I can get this to work. Hold on a second. Let's see if I can get mine. Oh, it should work this way. Let me do it this way. Labs 210. Ah, yeah, here we go. All right, so what I'm going to do is share this tab instead. So now you see basically the website. And I was asking you, please read this. What this does is, this is from that admin magazine. And the nice thing about this is that this particular article, this first one, is about portable home directories using the System D Home D. And it talks about all the problems they're having with it. This is not a new problem. This is a problem that has been solved several times throughout computing history. And the way they're approaching it is an entirely different model to make these roving home Ds. I want you to think about this. Let's say you have a home directory on your Windows box. You plug in a USB. You do your thing with your Windows box. You unplug it. Your Windows box reboots. There's no history of you anywhere on that computer. It's all on your pen drive. You go to another Windows computer, you plug it in, it initializes, and it says, and all your stuff that you've been using is now available to you. You pull it out, all the stuff that you were playing with, all the history, all the tracking it, cookies and everything disappears, machine reboots. That's the long-term goal of Windows. That is also the long-term goal of this systemd home D, where you could go to a Red Hat box, an Ubuntu box, any flavor of Linux that's relatively modern, I like within the past 3 years or 2 years. You plug in your USB, you do your thing, and everything is saved on the USB, go away. Now, next evolution in that, you're not going to be using a USB. You'll be using Dropbox, Box.com, Google Drive, Microsoft OneDrive. Everything you do is going to be under your login somewhere out in the cloud. And the operating system will be an ancillary to get to your data. This is the future. You want to invent it, you want to be involved with it, you want to get on the front end of that wave, and you'll make more money. Okay. The guys that are taking care of legacy systems aren't making as much as the folks that are implementing new systems. This goes for guys and girls too. Same thing. Okay. So this is why I want you to read this stuff, because it's important to your future. Okay. And I'm assuming you don't want to do some low-level job like changing computers for 20 years, because the day will come where computers will be a pair of glasses and you'll be able to do things. Do I think hardware is going to go away? Good question on Flatpak. Do I think hardware is going to go away on cloud computing? Let me ask you this question. How many of you have repaired a television or a VCR or a radio? Or have you ever taken in one of those devices within the past 5 years to get repaired? That's my question on hardware. It's going to get to the point where it's so embedded, so small, there's just no way to fix them. Now, what will be needed is people in physical buildings, like what they do in Google, is the tech that's in the building gets a message, replace server 21, and they find the rack, they see the server, they yank it out, they put it in a box and they ship it somewhere. They also take care of heating and air conditioning. They take care of the building. They take care of electrical. There are not technicians in computer rooms anymore, okay? The boots on the ground that are in computer rooms are simply parts changers, okay? Now, the area of Flatpak and snaps is something that goes outside the discussion of what we were talking about today, but is what I would say closely coupled, okay? Let's talk about abstractions, and that's exactly where this information is all about. So I'm going to click on over here and click stop sharing on this one and go to sharing on this computer. Whoops, I need to do a new share. This screen. Okay, so now you see my desktop and you see two windows, one with the backwards clock and the other one, and the other one is a VM that I have like 100 days left on VMware Workstation. So I will probably drive it, write it till the end, and then move to VirtualBox. And it's not hard to convert a virtual machine, but it's a real pain, right? So let's have some fun with this. What I want to do is, since system D is our target, and what we're going to talk about in system D is I want you to notice when you type in system D status, okay, that's all I did, system D status, all this information comes up. Notice the snaps. You can install Snap on Red Hat and you can install Flatpak on Ubuntu. Okay, they are basically variations on a theme. They both work very similarly. And you can see all this stuff is running. That's a lot of stuff running. Okay, network manager. You got stuff in here for Firefox. You got all kinds of interesting things. And the book or the articles I asked you to read, the second article has a fantastic article on, I'll bring it up, go P2 here. If you go to P2, as in part 2 of the articles, it's talking about isolation, okay, and security. I highly recommend you read these articles because it will help you in your test, okay? Because system D is the future and you need to know it, okay? Now, we're going to talk levels here, okay? So let's see if I can bring up my curious to see if this is going to work, because I fire up the Jupyter notebook only when I need it. If this doesn't work, I always have a plan B. Okay, fine. Could be I have networking issues. I have been battling all sorts of problems this morning. Okay, the screen you should be seeing is, it looks like a white screen and you see the Jupyter notebook. And, or are you seeing, I can see through the webcam. Okay. All right, what I think I'll do is I'll go back to the Linux management. I just wanted to see how 2 cameras would work. So let me turn off this computer. Because when you log in twice on Zoom, it seems to think that the second login is the host. When you're like, when I log in with my credentials. Now let's see what happens here. All right, I'm going to stop a share and go into a screen share, and I want to do a new screen share. I'll go to this one. So you should see. Don't you love technology? Well, if it all worked. Now, do you see the Jupyter notebook with the login? It should work now. Please say yes or no. Gone again. Okay. I want screen 2. Share. Oh, you know what this might be is some of the headaches I'm doing with X Windows. Let me turn off X Windows. And X Windows and Windows don't work real well together. So I recommend it. there? Greetings, how are you? No, no class. I'm just doing some recording, so I'm online. That's okay. So you can see Jupyter now. Okay, good. All right, what I'm going to do is log in. The Jupyter notebook is where I'm going to put some notes for this class. Okay. And it's on a different machine, mind you, so I'm going to have to make note that I remember. Help me remember to go look in my notes. Too many things. There's some heating and refrigerating guys working in the building today. So if you hear noise in the background, that's why. Okay. All right. MJC. I want to go to here and here. And then I have this system D directory. And what I want to do is create a new text file. I'm assuming you can all see this fairly well. And I'm going to call this 2022-0404 version 2.txt. All right, all the way back to where does this system D fit? Where does it fit? Okay, let's talk about, let's start at the top here. Chrome. When you log into Chrome, the browser, not Chrome OS, okay? What ends up happening is that each tab has its own namespace. We've talked about namespace a little bit, but if you don't understand what that means, please go learn it, because think of namespace as an environment of protected memory that another namespace cannot collide with it, okay? So each browser has its own namespace. Each browser can have something, each tab can have something in it called a PWA, which is something called a progressive web app. For example, I have one that's Zoom, and I have another one that is Outlook, okay? They are both progressive web apps. They run completely independent of each other on Chrome. And if you open up the Chrome utilities, you can see how it separates out the memory, okay? This is coming to a future near you, more and more of this type of thing. And now the next thing that we have that's in this, working from our user mode down to the land of the kernel, okay, is we have Flatpak and Snap, okay? Now, what these do, this is mostly on Red Hat, and Snap is mostly on Ubuntu and Clan, okay? It's not die hard, okay? But for example, if I go over here and just open a terminal and type in snap list, it shows you all the snaps that are loading on my machine, okay? Now, what are these? Well, just like we talked about namespaces, Flatpak and Red Hat, they're doing the same thing. Let's call it protected. This is actually fairly good namespace for apps. And I'm going to capitalize this. This would be, I guess I should say desktop app. Let's say you want to experiment with LibreOffice. You can load a Snap or a Flatpak for LibreOffice, and now it works just fine. What is the advantage of using these things? Well, it makes it a lot easier for the developer who is creating, like one of the things I have played with. I had got my ham license by accident the other, a couple of years ago. I went in and did a test and down at DEF CON, and I passed. I haven't played with electronics and ham radio since high school, but you know what? Ohm's law hasn't changed, and I passed. It was pretty cool. It was quite the boost to my ego. All right, now let's see what this is. Chirp is ability to program your particular radio with frequencies. And there's all the radios, blah, blah, blah. What this guy has done, he's actually on payroll for various manufacturers of radio to keep this maintained. Notice it's for this and for this and for this. You've got Windows and Mac, and he writes it once and puts it in a flat pack, and it can now be distributed across all platforms. Okay, now that's the main push here, cross-platform. Okay, so it's protected namespace for desktop and cross-platform. So you only have to develop it once, and you basically wrap it, and you can shove it onto different machines. Okay, Windows, Mac, and accordingly. Now they're in different states of progress down this road. Okay, so that's now Flatpak and Snap are designed to run on a machine. Okay, this is designed to run. I'll put that on here. Runs on one machine at a time. Okay, so the idea here is you as a user install a Flatpak and it runs on that machine for you. Okay, so one machine at a time for user. Okay, all right. Now the next level of abstraction is called Docker. And then we have basically LXD/LXC. Those two kind of go together. They're not separate. One's a daemon, one's the client. This is how Christini runs on Chrome OS. They're using the LXD. Docker. Oh, there's different. I'll just put the buzzword here. Happens to be containers. Okay. So container technology is not going to go anywhere. It's just going to continue to get better. And the better you know this is where the hot stuff is right now. Everybody wants to move to microservices, containers, to make things rapidly deployable and changeable. Okay. They call it microservices. It's more of a buzzword than anything. But what this is doing, microservices, is it allows you to take an application. Here we have this magic thing again, net protected namespaces. Oh, darn. I'm in the browser. X Windows doesn't behave for him. So I have to do copy, right click, paste. Name protected namespace for server apps. Okay. For example, your web server, HTTPD, Apache, A-P-A-C-H-E. Okay, that does not mean American Indian. It means this, A-P-A, Apache server. That's why they call it Apache. Okay, all right, because it had so many patches in it, they had to actually rebuild it more than one. Okay, so it's protected namespaces by server. Okay, so let's spell server right. All right. Now, how do you manage these things? Well, this is all the rage right now. We got Kubernetes, which you see in print as K8s. And then, oh, wait a minute, you can't run just Kubernetes. You need a layer underneath Kubernetes so you can move Kubernetes to another web provider. And those are called Linkerd. These are Linkerd and etcd. If you don't want to know what I'm talking about, don't worry. This is way beyond the scope of even my advanced Linux class. This is the cloud stuff. This is where your future is. And one way I recommend to getting into cloud is go find some free ways. They are out there. Free certifications that you can get for AWS, Azure, or Google. Pick one, learn it, and let me say this. There is an argument and I'm doing a side thing, is that it's not the tool, or I should say it's not the language. Okay, so if I want to teach you programming, what if I chose to teach you Scheme or C++ or Rust or whatever language of the thing is? The argument keeps being said, it doesn't matter what language you learn. You're going to have to learn different ones. There is beginning supporting evidence that you should learn one language. Pick it. I don't care which it is. To a very high level. Become a god in the language of choice. And I'm actually going to put Bash up here. Bash and shell in general. Okay. And of course, Python. My favorite language. All right. Why? Here's why. 1, 2, 3, 4. Success breeds success. I could spell right. And the evidence that this is coming from is actually coming from other disciplines. Let's say I am a scratch golfer. And if you know anything about golf, which I don't, I found out, what is a scratch golfer? Oh, that means you hit everything on par. That means you're a really good golfer. Oh, okay. Let's say I'm a scratch golfer and I want to go pick up a totally new sport. I know what it feels like to be really good. I'm going to bring that same discipline and focus to whatever it is I decide to learn. Okay. So let's say, I'll just say from golf to programming. Okay. This also goes for learning languages. So if you know, just for the sake of argument, Bash at a super high level, and you are the guru, picking up on another language like R, you know what success feels like. Success breeds success. Okay. All right. I'm a little off topic, but the reason I'm saying this is we have cloud providers. Right now we have 3, right? Well, there's actually more than that. There's three big ones: Google, Microsoft. I'll use their stock symbol. Apple's not in the space as much as you think they would be, and Amazon, AMZN. Okay, and I'm not sure where Apple's going with their cloud stuff, but they are working on stuff. Okay, now we have, look at business history. We have the big 3 car makers, right? GM, Chrysler, and Ford. But we now have Toyota, Nissan, which used to be called Datsun, Mercedes-Benz. There's consolidation in the market. We're going to see that happen again. So right now, there's smaller cloud providers out there. Salesforce and their Tableau. Okay. There's other models of cloud providing, or providers of cloud services that are coming into focus that may be very disruptive. Microsoft has already done something very interesting. They have, OpenAI was originally started as a nonprofit. Let's make sure AI doesn't create Skynet. Well, guess what? Microsoft was behind the curve on AI. Said, we're going to give you millions of dollars, but we want your technology and we want you to help us develop ours. So OpenAI said, okay. Now there are services you can buy through OpenAI, you can rent. And that's just AI, okay? This isn't about software development. This is not cloud providing, things like software-defined storage, software-defined network, blah, blah, blah. Software-defined compute is a thing now. So we're seeing the model of computing change because right now the cloud providing is the next level of abstraction, virtual machines. Okay, we all know this technology. We got VirtualBox, VBox, and then we have KVM, QEMU, which I recommend you learn those for sure, because that's what VBox is built on. VMware, and then you have I think Apple's product is called Parallels. Is that what it's called, Parallels? Or is it Boot Camp? I think Boot Camp is dual boot. I don't know Apple. I can't afford one. Well, I won't afford one. I can't justify it, okay? Okay. I'm going to be a little stupid here and say really, 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 really well. Okay. Now, as I'm leading you down the road here, is it what you see, Chrome browser, tabs, namespace. Then we have things like Snap protected namespaces for desktop apps running on individual computers. Then we have protected namespaces for server apps, okay? Node.js, blah, blah, blah. And these are then the management tools to manage your Docker container, okay? And then you have virtual machines, okay? And we're gonna get to where systemd fits and why it's so dang important, okay? All right, so we got our cloud providers, the argument, why go learn something, really learn any one thing? This actually is also true let's just say this. I'll say music to programming or anything. Let's make it really obscure, say art. Let's say I'm a world-class artist and I want to learn programming. I know what it's like to be a world-class artist. I'm going to apply the same discipline of mind to programming that I do to art. If you are a Joe average at everything, guess what you're going to be good at? You're going to be a Joe average at everything. Okay? It's okay to become really good at one thing because it spills over. This is preliminary neuroscience that I've been following. Okay. And then I think what I'm going to do is separate this out. This is going to be called side rant. Useless information to make your future a little less painful. Okay. MRI scans and CAT scans of programmers. Now, they use both beginner and advanced. And here's what they discovered. I think this is utterly fascinating. It's not language, because we have a locus in our brain that is optimized for language. Okay, that's why, little kids can seem to be fluent by the time they're 5 years old and they can't read yet. Okay, there is also a section in our brain that is dedicated to math. It's also not math. It's also not related to music. Okay, because there is a special section in our brain that lights up when you listen to music. And this part I think is really interesting, is that there's our visual cortex is optimized for faces, human faces. Okay, it's actually optimized. All right. Now, what does programming do to the brain? It basically does this. It lights the whole thing up, including the part that recognizes human faces, which is, there is something called face blindness. It's a very interesting side jaunt into the world of neuroscience. You can be face blind. In other words, you don't recognize people's faces. You'll recognize their gait, you'll recognize their voice. And if you've ever met somebody that's got face blindness, you know it. They won't tell you, but you can kind of recognize the symptom. It's really interesting. Okay. So when you learn how to code, a whole mess of subsystems in your brain light up. So this leads credence to when you have Alzheimer's, one of the things that keeps Alzheimer's at bay is the number of years of education you have. Now, why? Well, you have something called cognitive reserve. So here you go, folks. You want to build cognitive reserve? Learn to code. All that to say this, that these cloud providers that we have today are going to mutate. And here's how it's going to mutate. Cloud providers started by giving you just virtual machines. Okay. Well, guess what? Cloud providers are now offering you namespaces, protected namespaces for server apps. Where's it going next? You betcha. Going back down to cloud providing desktop apps in a tab. If you bring up Outlook in a tab on Chrome, it's say, do you want the PWA? which is a progressive web app. It's basically more and more is moving into the cloud. Less and less is going to be on your PC. Just fine. I'm not a big fan of that. I happen to like to control my own destiny. Even it gives me heartburn and it hurts. So all this to say, where does systemd fit in this? Here's the fun part. Systemd it's not there yet. It's evolving to support all of these. Okay. So you can learn one set of tools, systemd, and manage your containers, manage your virtual machines, all from systemd. If that doesn't get your interest, then maybe you don't want to do this job. To me, that's utterly fascinating that I can have a tool that's native on my Linux distribution that gives me the ability to manage and control applications and server apps and virtual machines all within the same ecosystem. That is cool. Okay. Now, how does this, right now it's not there yet. Okay. Systemd for containers, this works. Okay. Systemd for virtual machines, this works. Okay. This works. And under the covers, it's basically KVM, basically, because KVM stands for kernel virtual machine. Now, let me give you a few little blips about this. Let me put these in different categories. And then I have Zen, KVM, and I'll put KVM by itself and then put KVM with QEMU. Okay. All right. Now I can't speak definitively for Zen, so I won't. KVM works fine for any additional kernel that's the same. So for example, if I want to boot Red Hat on Ubuntu, no big deal, because they're both using the Linux kernel. Okay. If I want to boot Windows on KVM, I need the QEMU, which means this allows for different kernels. I mean, completely different architectures, different kernels. So I can compile a kernel for MIPS and run it on my Intel architecture. Okay. Allows for different, I'll just say architecture. Okay. And the same thing here. Allows for multiple different OSs. Okay. Notice this, it's all on the same kernel style. Okay. Now, systemd will support both flavors. So you can load a Windows machine via systemd at boot time on your Windows box. You get that figured out and you make that work. You need to write it up and put it on a blog. I've had, I've got one student, former student, who was a guest speaker he travels all over the world to do some of the stuff that he's been working on. And he actually stopped by Modesto and said hi, because he started his career here. He was a very focused individual, very, very, very smart. But it wasn't just raw talent. He put in super amounts of time into this. And he became a security researcher. He's also fluent in Spanish and Portuguese, because he's from South America. And so he's been traveling all over the world doing security conferences. And when he was at Modesto here, and here's a guy that's making, probably $500,000 a year. And I asked him, knowing what you know now, what would you do differently? He said, I'd start a blog sooner, because it clarifies your thinking and it helps other people know what you've been doing. So, side rant, side suggestion. Well, I'll just say side hint. You take it for whatever. Your mileage may vary. Your mileage may vary. Okay. Start a blog. And this is important because I talk about timesheets in my final project file. I talk about keeping track of your learning journal. I talk about portfolio. It's all a blog, folks. If you don't have one, start one. And keep track of kind of the things you would want to learn. You don't have to put it on the web. Just start it locally. Create a file structure with cool things you're working on. Use Google Keep or whatever you have for note-taking, and start keeping track of some of this weird stuff you approach. For example, I don't know, something that could save you 100 million hours of time is that little suggestion that I gave you. Okay, if this is a bash script, okay, what's it doing? That's a short little save. That little shortcut there gave me a huge raise, not once, but twice at 2 different jobs, because it basically gave me the ability to print email and have it sent to their email box. So they don't have to do, export, import type garbage, okay? All right. So, and I will just put this down here. So if you don't know what that means, you will need to know what that means for your test. Whoops. Control V doesn't work quite right. Control V works. Okay. This is in shell. It pretty much works in any shell. Okay. Start a blog. So if you don't know what this is, use this as your starting point. I'm going to start a blog and I'm going to explain how this works. Okay. Explain the following. All right. I'm going to put that like that. Okay. Now, I've gotten through most of the underpinnings of our good friend sysd. Now, let's go tinker. Sysd. Now, does this come through? Is it visible with the red, or does it work better with the blue? I honestly can't tell you. Blue? Okay, because I can make the blue one a little bigger too. Blue it is. In the classroom, the red works better. All right, so here we have system control status. So notice it goes to a 23. It's got an automatic pager in there. All this lovely stuff is running away. So I can do man on system control. Look at all this fun stuff. And it gives you 1,000 gazillion things to go read up on. If you, now you're in a Linux class, I am making the assumption that you have a Linux VM running somewhere. If you don't, why are you in the class? You should have at least a live Linux distro booting and running somewhere. And I'll show you how to make that work in a second here. So it's showing you how this all works. Look at all this fun stuff. Doesn't go crazy. It just goes on and on and on. This is quite the man page. But if you're lazy like me and you want to speed things up, you go to myacm.acm.org and you log in with your web account, which is different than your actual login. And you pay your $19 to become a member. Then I go down both of these. Now, the difference between Skillsoft and O'Reilly, Skillsoft is specific for learning certifications. Okay, that's what it's for. You want some more practice on the Linux Plus, Linux Pro, go here. You want to learn something new, you go to O'Reilly. Click here. And since it sees me, notice it wants me to log in again. It wants to verify that I am an ACM member so I can save a bunch of money. Because O'Reilly is not cheap. Okay. There's other companies in this space that do the same thing. Okay. That's awfully big. Reduce it down in size. And I want to go to here, this book. Now, I like to learn from books because then I have basically the ability to skim through it first time and get an idea of what I want to learn, and then say, okay, now I want to drill down a little deeper. So I have the ability to do that. Doing this stuff on the web, you can do, but you have to be really focused, because what I've found is you do a little side search and then before you know it, you're searching on cat videos chasing mice down a hole, and you get sucked into the wormhole of, whoops, I'm off topic. Okay. So here's the systemd, and there's a whole chapter here on security. Okay. And then they have a bunch of stuff. Okay. Well, this is chapter 1. I want to go over here. And I want to go down to there's some really good stuff in here. Oh, Journal D is phenomenal. Oh, I need to show you this. This is so cool. This is how we used to do logging. We would have syslog, and syslog would collect all the logs to a log server, and then you had all your logs kind of spliced into this big, huge mess that you had to unsplice to be able to get the data you wanted. And then you wrote a lot of Perl code using regular expressions to strip out what you need. Journal D cleans this all up, okay? And they explain pros and cons of the old way, and they explain the pros and cons of the new way, okay? Now, Journal D is just the same way. You can say, let's look at this. It's called journal control. Query the system journal. Now, what goes into this? as much or as little as you want based on your systemd information. It looks a little bit like dmessage, but it also has all the user app stuff. But notice it says 29. Why is it 29? I'm not on 29. Uh-oh, I have the wrong host name. This is a bug I'm actually working on right now. So I'm going to fix that right now this second, because it should be matching the host name. This is giving me heartburn using Ansible in the classroom, okay? So I want the actual name of my host, which is 231 VM. Now, let's see what happens. I'm going to run that same command. Is it going to show me the old host name or the new host name? I don't know. Let's see. It gives me the old host name. So that tells me that this is written at the time the journal is created. So I have to reboot and look at the latest entries. Look at all this stuff. Isn't that amazing? It gives you so much information. And then the flags, you can do something like XD and then look up something specifically like loop. Whoops. XD gives me the extended format. Okay, so you can look at anyway, journal, this helped me troubleshoot some problems with the Jupyter notebook in a shared arena where each user gets their own Jupyter notebook, okay? So using journal D, but what I want to do is go over here and bring up the article I want you to read, okay? So 210, labs, site. Okay, I want you to read page 2 or part 2 and look at this isolation. Okay. Now, Docker allows you to do containers and images. So does systemd. And it shows you how to manage containers with systemd, okay, using this thing called nspawnd, okay. This, to me, is, oh, you're kidding me. I don't have to go learn Linkerd. I don't have to go learn Kubernetes. I don't have to go learn etcd. All I need to learn is nspawnd. Oh, cool. Sign me up. And it shows you how it's working. And this MKOSI, this is how you create a new virtual machine on your machine with using systemd nspawn. You use this tool called MKOSI, and it creates a bootable subsystem. And boom, there it is. This is a lot easier than the instructions that I gave you here. When I did notes, I gave you, oh, I didn't put it in there. Oh, well, never mind. You don't have to worry about that. All right. So part 2 is about security. And the fun part about this using the security is you don't realize how open your machine is. This, to me, was worth the price of admission to buy a subscription to this magazine. This one article opens up a whole new world for me on how to secure a box. And they went, this is fascinating. So how do you do this? Well, it's pretty simple. And it gives you, they tell you where to go. And I've read several things by this fellow here. I believe he's based in Germany. And his articles have been really thought out, short and concise. Really, it's good stuff. So how do we make this work? Let's take a look. Remember yesterday or last week, I kind of tried to run that command and didn't quite remember it. So it's systemd dash analyze, and you run it. And then you type in security, and it shows you what is and isn't safe. This would make a phenomenal blog entry. Here's my Ubuntu server VM. I'm booting it in VirtualBox, whatever. And you're running this because you don't have to add anything, you just run it. And if this is how I hardened my Ubuntu server using systemd, that would give you a very serious blog entry. I would read that. Okay. All right. So that's just one of the many things you can do with this. There was another one I stumbled into. There's a bunch of add-ins that work with this. I think it was in the book. If you go into editing, here we go. This boot process is really important. This kind of, if you start here, everything else starts to make sense. And the nice thing about this particular book is it takes you to videos you can go watch. Okay. So it starts and it explains the difference between the old school and the new school. He explains it much better than I do. And you go down, list dependencies. It shows you what needs what. Okay. And let's see down here. So this, you run this, and then you can say, use the time option. And then you want to see, first, let's use the blame option to see who we want to blame that takes the longest to boot. That's kind of cool. And you can specifically, and then use a critical chain. What this is giving you dependencies on how things work. Okay, and then it gives you some differences between Red Hat and Ubuntu. Now, here's what I'll say about what should I learn, Red Hat or Ubuntu? Well, that depends on where you go to work. Find out what they're running and learn what they're running. But this is what I've noticed. Stateside, it's mostly Red Hat. Everywhere else on the planet, mostly Ubuntu. Okay. All right. And you can look at the dbus information. Now this, I have not mentioned, but this right here, watch what happens here. I'm going to copy this. And since I'm on my VM, I'm going to do this. All right, watch what happens. So I changed it, okay? So now if I hit reboot, hopefully my screen is still being shared here. Oh, I shouldn't have done that. I just wiped out my, my Jupyter notebook. That's okay. Uh-oh. Where's my GUI? It's all gone. That's exactly right. You don't want a GUI on the server. But I can do, I believe, start export. Ta-da, there's my GUI. Now I can change this back by using this, and I believe it's called graphical. Yeah. Now, when I reboot, it's going to give me the graphical. That little point there is something that will show up in your test. I guarantee it. Okay. Because this is, you don't, generally speaking, you don't want X windows or a GUI on a server. You don't, why spend all that horsepower running that stuff? Okay. So let's say, for example, I'm going to run, here, let me go back to the blue one. Oh, it's got the wrong. LX term is the name of it. Oh. Oh, LX terminal. So there's the blue one. Make it a little bigger. And now if I run my systemd, there's what it is, syscontrol. Now let's look at the journal. There's a whole lot less stuff running because I actually fired it all back up, so it doesn't make sense. So had I run this without starting up the X windows, a lot of these would go away. So how do you secure your machine? Don't run X. That's it. Step one, if it's a server. That's very handy. And on that note, I think I'm getting really close to the end of class here. So what I'd like to do is ask some questions and say, this was a lot of information today. And give me something to explain a little deeper to help your understanding, okay? Okay. This is the way you're supposed to reboot your machine. System, control, reboot. That's the way you're supposed to reboot your machine now. That's the quote modern way. I sometimes still do it the old way. But what's nice about the system control reboot is you don't have to be root to reboot. There's actually a service in there that does reboot for you. No questions, huh? Okay. You're ready for a final. Okay, folks, I will stop the share and stand up here, let the blood get back into my feet. Review the recording. Yeah, that's why we recorded this monster. It was an awful lot of information I threw at you. And it's in the big scheme of things, I would say the majority of today's lecture was outside the scope of what you need for Test Out Pro, but it's 100% of what you need for a job, working in the industry, and keeping the job once you get it. Okay, this is truly where the future's headed. You want to know this. Okay. On that note, I will stop the recording. And office hours are going to be